Ladies and gentlemen, welcome again to the Trigonometry Chronicles presented by Fraser Nation Entertainment. This is your host, Timothy Fraser. Today we're going to be looking at law of sines. These are exciting times because this is the stuff that's not reviewed from geometry. We are going to be able to solve right triangles, and they're not going to be right triangles. Let's go with that. So, in the law of sines section, there's two objectives that we need to be able to conquer by the end of this lesson. Number one, students will solve non-right triangles using the law of sines. So remember, we do not have right triangles. And students will be able to find the areas of triangles using a combination of given sides and angles. So remember that formula, 1/2 base times height? Yeah, that's coming back in a major way. So some things I need you to remember. I need you to look at my arrow. For my iPhone people, make sure that your calculator does not say RAD mode, okay? Make sure it does not say, I think it's GRD. It has to say degree, okay? Right here, it has to say degree. So for my iPhone people and my Android people, okay, remember these calculators we're using, you're able to use them on the phone, but they have to be in degree mode, okay? So we cannot have RAD. So if you need to change it, here's the button right here in iPhone. So DRG for degrees, radians, and gradients. Keep hitting this button until you see DEG. Okay, this is what you want right here. And then over here for my Android people, if you don't see DEG right here, then hit Shift DRG, Shift DRG until you see DEG, because we need to be in degree mode. We'll work with radians soon enough. I know you guys are anxious for that, but we'll get to that at a later time. Remember that angles in a triangle are used with capital letters. They're opposite sides or lowercase. So if one triangle is capital A, then the opposite one would be lowercase a. Remember, okay, I can't stress this enough, you're not using the Pythagorean theorem in this section. You cannot use the Pythagorean theorem. The reason is we are not working with right triangles, okay? Just like this triangle right here, you are not working with right triangles, so do not use the Pythagorean theorem. And remember, when we say solve triangles, that means calculate all three sides and all three angles. So, like I said, in this section, we're going to say it's a lot of work, okay? But it's basically easy calculations, okay? It's basically easy formulas, okay? You have to be able to know which formula you plugging in. So anyway, without further ado, let's go ahead and get started. The law of sines is used for solving non-right triangles. So here we have a proportion. If you remember back in your Algebra 150 days and your Geometry 250 days, proportions are fractions that are equal to each other. Okay, this is where cross multiplication comes in. So in this section, you're going to be using cross multiplication, okay, in order to solve for a variable. Okay, so little a, little b, little c, big C. It does not matter what set of proportions you use. These are equal, okay? These are equal, okay? In my presentation and on my examples in class, I usually go for this one. And remember, it goes for any triangle as well. Ugh, that is really ugly. Let's go ahead and get a triangle out here. So shapes and triangles and okay, we can go with that. Okay, so remember, let's call this triangle EGF. Okay, it's going to be the same thing, So the opposite of F is lowercase f. The opposite of capital E is lowercase e. Opposite of big G is little g. And then this would be sine of big E. Remember, all over little e. And I mean, they match up, okay? So sine of big F, if I could write tonight, over little f, and then sine of big G all over little g. Okay? So you got to remember these things. Let's go to the next card. Another set of formulas that you really need to get familiar with, area of triangles, okay? It is still 1/2 base times height. I would go into that, but I want to just kind of get in and get out. So when you have two sides and their included angle, so let's see if we can get an appropriate triangle here. Okay, so say if I had a triangle and this side was 8 and this side was 12, that included angle is going to be this angle right here, the angle that's in between your two given sides. Again, here's a triangle. Let's say 10 and 19. Okay, so triangle, two sides are given. Here's their included angle. Okay, so in your examples, I'll show you. Remember, this is little c, little b. So you have two sides and their included angle right here, big C. That goes, so basically it's whatever angle they give you, okay, and then you're going to use the two opposite sides. Remember, no Pythagorean theorem. Over here, this is when you're given all three angles, or you can actually calculate all three angles, and you're only given one side, okay? So this is when you have only one side, okay? And that side, its opposite angle is going to be on the bottom. So if you are given B, big B is going to be on the bottom. If you're given C, big C is at the bottom. And remember, a geometry fundamental, remember there's 180 degrees in a triangle, okay? 180 degrees inside of a triangle. So in order to find the third angle, if you have two angles, you need to subtract the given two from 180 degrees. But you'll see that in examples. Questions? All right, let's go to the next card. All right, so let's go ahead and erase this stuff. So basically, I feel it's more important to give you examples than, just give you theorems and formulas and blah, blah, blah. So I put our formula right here that we're going to be using. Remember, I'm probably going to be using this right here. And you have to go with what you're given. Wow, this 98.25 kind of snuck up on me, didn't it? Yeeters! All right, so remember, you have to put in what you know so we know what to solve for. So in the example, it says solve each triangle and round to the nearest tenth. Okay, remember that's the first number after the decimal. So first and foremost, let's plug in what we know. So big A is 40 degrees. Okay. Let's see. Big B is 59 degrees. And little c is equal to 14 degrees. Okay. So we want to solve for the third angle and these two sides that we don't have. I will tell you the easiest thing to do. Let's just go ahead and get rid of this exercise right here. 180 degrees. So we need to find big C. So big C is going to be 180 minus 40 minus 59. Okay. And when you do that, you're going to get C is equal to 81. Okay. 81 degrees. All right. So let's go ahead, get in red. So this is the new stuff. We've just found 81 degrees. Okay. Now, doesn't matter. Pick a side. You're either going to use little a, little b, and then you're given big C. So up here, I'm definitely going to be using this one. Okay. And then it doesn't matter which one you use here. So let's say we want to solve for little a. Okay. So to solve for little a, we need to do sine of big A is equal to divided by little a, which is equal to sine of big C over little c. Okay. I'm using little c because they gave me that. Okay. And I'm using A just because, A comes before B. But we know big A, we know big C, and we know little c, and we need three out of the four because we're about to cross multiply. So plug in what you know. I have sine of 40 degrees, okay? Big A is 40 degrees. I don't know little a, which is equal to sine of 81 all over 14, okay? Here's my 81, here's my 14, here's my 40. And when I cross multiply, first and foremost, I get 14 times sine of 40 is equal to little a times sine of 81. Okay, let's put a little times right there. Okay, and then how do you get rid of things away if they're multiplied? Well, you divide, of course. So here is sine of 81. Whatever you did to one side, you got to do to the other. These cancel out. And remember, I want my variable on the left. Little a is approximately equal to, it should be approximately 9.1. Okay? So here's another side that we figured out, 9.1. And then the only thing that we have left is we need to get rid of that B exercise so we can go ahead and complete our triangle. Okay? So to solve for little b, same thing. I'm using this one because it was given to me. So sine of big B over B, little b I'm trying to solve for it, is equal to sine of big C over little c. Okay? Plug in what you know. So I have sine of 59 over B, I don't know B yet, is equal to sine of 81 over little c. I'm sorry, not little c. That is 14. Y'all bad. My fault. Okay. Cross multiply. And you get 14 times sine of 59 equals to b times sine of 81. Divide both sides by sine of 81 because we want to get our little b by itself. Cross out, b on the left. And when you plug in your calculator, 14 times 50 sine 59 divided by 81, you should get approximately 12.1. Okay, so b approximately 12.1. Okay, so look at your triangle. I just solved my first triangle in our example. These are three I was given. Here are the two sides that I solved for, and then here is the angle that I solved for. Questions? Do you have any questions? No questions? Okay, let's go ahead and plug in my next example. Okay, for this next example, I'm going to go ahead and work this out again with decimals. And then the third one, hopefully you're working with your calculator. So you're getting the answers that I'm getting. You're working alongside, pausing the video, because if you see it in the video, it needs to be in your notes. Hello. So when I'm checking notes, I need to see all these examples. But, after this next example, I'm just going to start giving you numbers, and you're going to be checking to make sure you get the same numbers that I get. Okay. So let's work in black. Let's plug in what we know first and foremost. Little a crossing big A, that's supposed to be 8.6. Big A, 27.3. Big B is 55.9. And so let's go ahead and work in red so we know what we have new. Remember, there's 180 degrees in a triangle, so in order to solve for big C, okay, I need to subtract, okay? So this is going to be 180 minus 27.3 minus 55.9, and you should get 96.8, okay? So big C, 96.8 degrees, okay? Now, we don't know little c, we don't know little b, but we know a. So we definitely are probably going to be using this one, okay? Remember, it doesn't matter which one of these two you use. So, I mean, I don't know. I just get used to this. But let's go ahead and use this one. Doesn't really matter to me. Okay, so we know little a, so we're always going to be using what we're given, okay? So in order to solve for little b, we got to plug in, okay? Plug in what we know. So first and foremost, we have, here we go. 8.6 on top, sine of 27.3, which is equal to little b, we don't know little b, over sine of 55.9. Okay? Cross multiply, you should get 8.6 times sine of 59.9, which is equal to b times the sine of 27.3. Okay? We did a little cross multiply just in case you don't know where that came from. And then we want to solve for little b, so we have to divide both sides by sine of 27.3 on both sides. Cancel. B is equal to, or approximately, okay? When you do this calculation, you should get 15.5. Okay? And then little c, same thing. Here's little c. We have 8.6 over sine of 27.3, which is equal to little c over the sine of 96.8. Okay, remember this is big C, this is big A, little a, and we're doing this one and this one. Okay, remember that's where that comes from. So, let's go ahead and write that out. 8.6 times sine of 96.8 equal to C times sine of 27.3. Divide both by sine of 27.3 on both sides because it's an inverse operation. So the 27.3, that cancels. C is equal to, approximately equal to 18.6. Okay. Okay, so here's my triangle. Okay, I was given this, given this, given this, and here are the three things that I solved for. Okay, let's go ahead and erase this. So for my third example, remember, DMS didn't go away, people. We need to be able to convert degrees, minutes, and seconds. So remember, this is DMS, degrees, minutes, seconds, and we need the decimal. Okay, so if we plug in the calculator, approximately this is going to be 7.92, And approximately, this is going to, well, not approximately, this is going to be 98.25. Okay, so let's plug in our big A, no, our big C. So this is 98.25. This is 17.92. And our little a is equal to 17. Okay. In this example, I'm just going to throw the numbers at you. You need to confirm that you got the same numbers that I do. Okay. So, big A, okay, when you do all your calculations, big A should be 63.83. Okay, so let's do 63.83. Okay, because we subtracted 17.92 and 98.25 from 180. We know little a, so let's try to figure out little b. I'm just going to set up your proportion. So we have our a, and we were given a, so we're going to use sine a over little a equals sine big B over little b. Plug in what you know. So I know big A, which is 63.83. I know little a, which is 17. And I know big B, which is 17.92. I don't know little b. When you cross multiply and do all that good lovely jazz, we're going to go ahead and get approximately 5.8. Okay, so this is approximately 5.8. And then the same with C. I'm going to go ahead and just plug in now because you are comfortable with this. So I have sine of 63.83 over 17 equals sine of 98.25 all over little c. Okay, let's go ahead and identify. Remember, this is big A, little a, big C. Okay, so when you plug in, C should be approximately 18. I believe that's a 7 in my notes. Okay, make sure you confirm that. So approximately 18.7. Okay, so I gave you 3 examples. It's in your homework. You should be able to be comfortable with this. Remember, in your homework, you need to show all your work. Okay. So anyway, let's get to it. Let's go ahead and do area of triangle. Okay, so find an area of triangle. Pretty easy. It's a lot of work. You just basically got to pay attention to what you're given. For my visual learners, I've drawn a triangle for you. It should be obvious from the formula itself, but I went ahead and just put the triangle in anyway. So if I'm given, let's go ahead and write this in black. If I'm given 78 degrees, little b is 14, and little c is 12, then, well, look at your equation, okay? Let's see. So 2 sides, included sides. So I'm given 2 sides and included sides. So here are my 2 sides. Which one is it? Well, I have to use this one, okay? So just plug in what you know, okay? I'm just going to say 0.5 for sake of argument. 0.5 and 1/2 are the same. 0.5 times 12 times 14 times the sine of big A, which in this case is 78 degrees. When you do that, when you plug that in your calculator, this is going to be approximately 82.2. Okay? So for A, this is approximately 82.2. Okay? Next, Let's go ahead and clear out. This one right here, we're given two angles and a side, okay? So instead of using this, let's shake that over. We're going to use these formulas, okay? Because I was given three angles and a side. So in black, I'm going to do this for my visual people. Okay, we have 22 degrees, we have 105 degrees, and we have little b, which is 14. Okay, so our other one wouldn't work, so we have to use these formulas right here. And so what do you have? You have little b. Okay, that's the only side that they give you, so we're going to have to go with little b here. But first and foremost, we have to do c. So we have to find big C. So C is equal to 180 minus 22 minus 105. So big C should be 52. Okay, should be 52 degrees. Okay, so knowing this, we now need to plug in. So that's what we're going to do. And actually, my apologies, it's not 52. You know, I don't know, 5 and 2, that's a 7. C really needs to be 53. My apologies. Okay, so over here, let's go ahead and put in 53. All right, now plug in. So K, and the reason we're using K, and this might be an extra credit on the test, I don't know. The reason we're using K is we can't use big A, because big A is already being used as the angle measure. So K is the area. So K is going to be 1/2, okay, times B squared, which is 14 squared, okay, times sine of 22 times sine, okay, I'm going to use C here, 53 over the sine of 105. Okay, so I'm using this equation right here, okay, because I was only given little b. When you do this in the calculator, I usually throw parentheses around here, so I would say times, and then in parentheses, I would do sine of 22 times sine of 53 divided by 105. That's how I would plug it in the calculator. And when you do that, you get approximately 30.4. Okay, that's your area. Okay, let's go ahead and do our next example. Our next example, we were given two sides, so we cannot use this. So let's go ahead and scooch him on out the way. We have to use this again. Okay. For my visual students, go ahead and plug this in to your triangle. I'm just going to go ahead and write it out. Let's see. So A equal to 28, B and C 14 and 9. So I'm going to use this equation again. Okay, I don't want you to get used to this. It's whatever they give you. Okay, and then it's going to be the opposite two sides, or the two sides that are making that angle up. So I'm going to type into my calculator 1/2 times 14 times 9 times the sine of 28 degrees. And approximately speaking, when you plug that in, you should get 29.6. Okay? So for C, you should have gotten 29.6. The final example that I need in your notes, let's go ahead and clear this out. is D. So we have two angles. We only have one angle here, so we can't use these. We're going to have to use, let's see if I can actually select it. I'm going to have to actually use these formulas again. So remember, we have to figure out that third angle measure. So let's go ahead, plug in. I have to find a third angle measure. So big C is going to be 180 minus 15 minus 113, and you're going to get 52 degrees. Okay. So since I'm given little b, I'm going to use this equation. Actually, let's switch it up. Let's switch it up. Okay, for my fourth example, and let's see how good my post-production skills were, because we just went through a major faux pas. We have two angles. We have one side, so we have to use these formulas right here. And I will put these in flashcards, but I will give them to you on the test. It is a good idea to memorize them, but like I said, I'll give them to you. We have to figure out big C because we only have A and B, so we're going to do 180 minus 15 minus 113, and we're going to get 52. Okay, and we were given little c, so we have to use this equation. So let's do 0.5 times c squared, so it's going to be 7 squared. Okay, and then in parentheses, sine of 15 times sine of 113. Okay, and remember, since I have little c, big C needs to go on the bottom. So I have sine of 52. So in the calculator, I advise you type these in. Order of operations should get you right anyway, because it's going to be multiplied before you divide. And when we plug this in, and let's go ahead and identify. I don't want to just throw stuff at you. Remember, this is your 1/2. This is your little c. This is your big A. This is your big B. This is your big C. And when you plug that stuff in, you should get approximately, and I don't know why this number is so low, 7.4. Okay? So you have your 4 examples. You have your homework. And you have questions to bring to me when I see you next time. So anyway, this is Frazier Nation signing out. Yeah, there it is. Peace.